Hello! Today I'm going to show you how you can graph a rational function. Now these are special functions such that you have a polynomial divided by another polynomial. And to see how I approach this, we're going to gather up lots of different information. Here's how this is going to work. So to graph this rational function, I'm going to look at the original function and the function in its factored form. So we'll go ahead and factor the top and bottom if we need to. We'll also be looking for the x and y intercepts. And this will come from either setting x equals 0 or y equals 0. A very important feature from these rational functions are the asymptotes. So we'll find the horizontal and vertical. The horizontal will come from comparing the powers of the top and bottom polynomials. The vertical ones will come from where the bottom polynomial is actually equal to 0. We'll also be looking for some common factors. These might create holes in our graph. And if we need some additional points just for the graph, we might throw in a few extra test points. Now, one great thing about this table, as you will see, is that this information, like the y-intercepts, the horizontal asymptotes, can easily be found from the original function. When we go to find, say, the x-intercept, the vertical asymptote, or the holes, it's best to look at the factored function to get all of that information. Alright, let's go ahead and take a look at our function and see if we can figure out that information. So the way our rational function is given to us, we see it is in the original form. Let's go ahead and put it in its factored form by factoring the top and the bottom. Fortunately, the top is already factored for us. Looks like the bottom needs a little bit of work though. So let's factor the bottom into an x plus 2, and it looks like another x plus 2. Now the next part of this, we need our intercepts. So for those y-intercepts, we're going to plug in x is equal to 0 and see what we get. Let's see, we plug in that 0. Let's see, lots of zeros floating around here. Looks like it equals just a negative 1/4. Now remember, this is a point, so we're going to write this as 0, negative 1/4. That is our intercept. Alright, now for the x-intercept, we're going to plug in y equals 0. Now if you're looking at this going, wait a minute, where's y? Imagine it this way. Y equals. So we want to know, when does our rational function equal 0? Now it looks kind of complicated, but the good news is it's really going to come from the top. Where does the top equal 0? Well, when x is equal to 1. So we will use this as our other intercept. So 1, 0. Awesome. Alright, on to finding some asymptotes. For the horizontal asymptote, compare the power in the top and the bottom. If the top power is smaller than the bottom, like it is here, so 1 versus 2, you can say that it has a horizontal asymptote right at y equals 0. Now let's find the vertical ones. The vertical ones come from a great spot. Look at the bottom of this rational function and figure out where the bottom is equal to 0. It's equal to 0 when x is equal to a negative 2. And even though there's two factors, they're both at negative 2. That's a lot of information right there. Alright, let's see if we can find any holes. And these come from common factors in the top and in the bottom. Now as you can see, I have an x minus 1 up top and an x plus 2 in the bottom, so they don't really have anything in common, which fortunately for us means no holes. Now we might need some additional test points, but we won't really know until we actually get into the graphing part. So as we go to graph this, you can see that I've already copied over a lot of information. Let's go ahead and start putting these on the graph. So I have a y-intercept at 0, negative 1/4. So put a big old dot right there. I have an x-intercept at 1, 0. Put another point right there. Now we can start plotting out our asymptotes. So we have this horizontal one at 0. We have a vertical one at -2. Now just with that information, we get a good idea about what part of this graph looks like. We know that it wants to avoid this asymptote, this vertical one right here. So I'm going to draw my graph like that. Now you may be asking yourself, well, how come you didn't draw it on the other side? Why didn't I draw it up here? Well, the reason is because I know it has to go through those 2 points, my intercepts. Now this is a pretty good idea of that half of the graph, but I really need to figure out what's happening over here as well. Well, this is where my test point is going to come into play. So I want to figure out if this is either on the positive side or the negative side, so I'm going to plug in a value like -3 to see what we get. Let's go back here. So let's plug in x equals -3, and it's probably best to just throw that in the original. So -3 minus 1, -3 squared, plus 4 times a -3 plus 4. Alright, let's see if we simplify all that. Looks like we just get a -4 over 1, or I can say that we know that it goes through the point, -3, -4. Let's put that on our graph as well. Let's see how that will help us. So also at the point -3, -1, 2, 3, 4, so we know that it goes through that point right there. Well, now we got the last part of this. So we'll draw in that arm as well. And there's our sketch of the rational function. Again, you might be asking, wait a minute, how come it doesn't say cross and then come back over? And the simple reason is that we only found this as our x-intercept. If it crossed this line, we would have found that point as well. Now this is a pretty good sketch, but let's go ahead and double check ourselves, and I'm going to take a peek at my calculator and see what it came up with. As you can see, it has a lot of those same features. Here's that asymptote right at -2, and it rises from the bottom on both sides. It happens to cross at 1 and then get closer to it on this side, and on this side it just stays on the negative side. If you'd like to see some more videos, please visit mysecretmathtutor.com.